Hello. Uh, I'm going to continue to do the questions I couldn't quite finish yesterday. Um, Let me start with this integral, which is quite an interesting one. By interesting, I mean trivial because I do further maths, and every time I see anything like 1 minus x, I think of a trig substitution. In this case, I think the nicest substitution I can make, I hope it can be seen when I makes myself smaller, is x is equal to sine squared u. That means if I plug in x into the denominator, I get 1 minus sine squared u, which is just cos squared u. Now I have to replace the dx as well. So if I differentiate both sides, I want to get dx is equal to the derivative of sine squared u, which is just 2 sine u cos u, which is just a double angle formula, but that's not going to be important. Now, if I rewrite the integral with this new substitution, I'm going to have, I have to change the bounds. Sine squared u at 0 is 0 when it's 0, and it's 1 when it's pi by 2. These are my new bounds. So I'm going to have sine squared u on my numerator and cos squared u on my denominator. And if I replace the dx, I get 2 sine u cos u du. I am going to take the 2 out by 2. This is just going to be tan u, which is just sine u over cos u times sine u times cos u du. The cos's cancel out. And now I just have to solve 2 times the integral of sine squared u du from 0 to pi by 2. Now, to integrate sine squared u, it's quite simple. It's just going to have to be rewritten as 1 minus cos 2u over 2 du. If I take the half out, I'm just going to be left with this. And lastly, if I actually integrate this, I'm going to have 1 minus cos pi, which is minus 1, minus 1 minus cos 2 times 0, which is 1. This is just 0. Oh no, this is pi. So this is pi by 2. Still a mistake. And this is 0. So this is pi by 2 plus 1. I think I'm missing something. Yes. I'm quite stupid. I integrated this wrong. I need to get rid of this. This is half sine u. Well, actually, this is correct. I need to correct this part. Half sine 2u in 0 and pi by 2, which is just pi by 2 minus 0 minus 0 minus 0, which is just pi by 2, and that's my answer. This is quite simple. I think another substitution that might work is sine squared u. That should work. But other than that, I don't know. Next question. This is from today's pack of questions. I just did this question, so it's fresh in my mind, and I've seen something similar before it. So I'm going to try to employ the same trick. First of all, I know that a, b, and c are integers. I'm going to write it down. Are all integers, and I'm going to use a trick. Okay, I'm going to write down b as c plus 1. Or actually, I'm gonna do c is equal to b plus 1. The reason I'm doing this is because I'm writing c and b as being two consecutive integers. What I'm trying to do is to rewrite all my variables in terms of some common variable, and I will get three formulas, all in function of the same variable. That means I can keep on generating as many solutions for ABC as possible. And that's going to be the way I'm going to be approaching the question. Now, um, a squared plus b squared is equal to b plus 1 squared plus 3. Just to check that I'm doing the right thing, I'll take out my notes. So I don't embarrassingly do it again wrong. Yes. And I'm going to expand this thing out. Squared is equal to b squared plus 2b plus 1 plus 3, which is just 4. And then the b squareds cancel out, 2b plus 4. Now, what this tells me is that a, or at least, yeah, a is going to be a even square number, which can be written in the form of 2n squared, where n is an integer. So I have 4n squared. Now, I can write 2b plus 4 is equal to 4n squared. I can make b the subject. And this is going to be 4n squared minus 4 divided by 2. Then b is 2n squared minus 2. And this is quite an important result because now I have a in terms of n and b in terms of n, and I also have b in terms of c. I know that c is equal to b plus 1, therefore b is going to be 2n squared minus 1. So to summarize, I have a, which is 4n squared, b, which is, well, actually, a squared is 4n squared, b, which is 2n squared minus 2, and c, which is 2n squared minus 1. Now, a is equal to plus minus 2n, but for simplicity's sake, I'm just going to write 2n. The negative case is going to be slightly different, but it doesn't matter as long as I have a way to rewrite ABC in terms of one common integer, n. So I have ABC. This turns into 2n, 2n squared minus 2, and 2n squared minus 1. So I can show that, for instance, n equals to, let's say, 0. I have 0 minus 2 minus 1. And if I do a squared plus b squared is equal to c squared plus 3. This is 4 plus 1. 4 is equal to, oh, my mirror is bugging out. 4 is equal to, and my pen is not working. Down here. 4 is equal to, oh, I see what's going on. I think I have to refresh my page because this is very much annoying me. Okay. Yeah, I hate using this iPad because I I don't have to refresh. Yeah, it's very annoying because now I'm losing time with which is very sad because my tablet is bugging out. Okay, I'm just gonna reopen Miro. But yeah, I'm gonna get 4 is equal to 1 plus 3, which is just 4 is equal to 4. That means it's true. So I'm just gonna show one more case to show that this is the case. Um, so I know this is true. And now if I try n equals to 1, I get 2, 0, and 1, which is 0 squared plus 4 is equal to 1 squared plus 3. 4 is equal to 4. We have the same thing as before. And I can keep on generating as many solutions as I want to infinity. So that's my way of doing this question, and I think it comes from this trick of relating C and B together. And the only reason I had to do this is because I've seen something similar before it. But yeah, this was quite a nice question. Next question, which I also had some time to think about, is quite an interesting one because my first instinct was to use induction, and I think I'm the only person who have spoken to you about this question to actually consider induction. Now, so I have the set 1, 2, 3 all the way to 3n, and to show that it can be split into 3 disjoint subsets that have the same total. Now, I didn't know what disjoint set is, but a disjoint set is a set that, actually, let me write it on my computer, is, oops, it's a set that doesn't, sets that do not share any common elements. I think that's the correct definition of it. I can quickly check actually. What is a disjoint set? Disjoint sets are two or more sets that have no elements in common. So yes. Okay. Now the way I have gone about doing this question actually is the following. So I know that the total of this set here is just going to be the sum from 1 to 3n. So I can write this as S, oops, um, S is equal to, okay, no, my iPad is again giving me issues. I'm not meant to write this. S is equal to the sum of this total set, sum of the set, which is 3n times 3n plus 1 over 2. And now I want to show that I can rewrite. So each of my 3 disjoint sets is going to be a third of S, which is just n times 3n plus 1 over 2. This is what the sum of one of my disjoint sets. Sum of one of disjoint sets. Okay, that's very important to specify. Now, what I'm going to do is to do the base case. So for instance, base case, let me try n equals to 2. So I have, my Wi-Fi is bugging out. Okay, now it works. I can't do the curly brackets. 1, 2, 3, 4, 5, 6. And I can rewrite this as, I have how many elements? I have 6 elements, so 2 in each. 1 and 6, 7, 2 and 5, and lastly 3 and 4. All of these add up to 7. So 1 plus 6 is 7. This is also 7. This is also 7. And this is the sum of this is 21. So base case n equals 2 works. Let me just for the sake of it, I'm going to do n equals to 3. So I have how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. I think each set is going to have 3 numbers. Now the sum of 1 to 9 is 45. 45 divided by 3 is 15. Is that correct? Yes. So how can I make 15? I can use 1, 9, and 5. 9 and 5. This might go wrong because I don't exactly remember what are the subsets. So it's me working it out as I go along. Another way to do 15 is 2, 8, and I think 4. No. 2, 8, and 6. No. 2, 2, 7, 4 is what? 2, 7, 6 works actually. 2, 7, 6. And lastly, the last remaining numbers are 3, 4, 8. Yes, they all add up to 15. So I've shown that n equals to 3 also works. Now let me go into my inductive step, or at least my hypothesis. That assume that t is equal to 3k 3k plus 1 over 2, and let t k plus 1. Okay, no, actually, let n equals to k plus 1. Let's just step that way to write it. I haven't actually wrote down the how to do the induction, so I'm kind of going, um, you know, wild. I haven't actually wrote this down. So I'm introducing. So this my new set is going to look something like this: 1, 2, 3. Then I have 3k, and then I have 3k plus 1. So this is going to be my new set. So I know until from 1 to 3k, this is just tk. And here, I'm introducing 6 more numbers. So I have, this is the correct way to do it. I need to check my notes. Um, if I don't get this right, I'm gonna get very angry. Oh no, it's not k plus 1, but actually what I did is k plus 2. Because that's actually going to make a difference. This isn't. Yes, that makes sense. So my new numbers are going to be, oops, 3k plus 1, 3k plus 2, 3k plus 3, 3k plus 4, 3k plus 5, and 3k plus 6. Now, if I add all of them up, this should give me 18k, so 3 times 6k, and 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is just 21. So this is going to be 7. This is my sum of the new terms that I'm adding up. So tk plus 2 is equal to tk plus tk plus 2 tk plus 6n plus 7. And the reason for that is because if I actually write this, k 3k plus 1 over 2 plus 6n plus 7, I am going to get I believe at least 3k plus 1 plus 2 and 3k plus 3 over 2. I need to check this is correct because this might not be true. So let me do the left hand side, not right hand side first. And if I do that, I get 9k squared plus 9k plus 6k plus 6 over 2, which is just 9k squared plus 15k plus 6 over 2. Now I need to do the left hand side. 9k squared plus 3k plus 12k plus 14 over 2. This is equal to 9k squared plus 15k plus 14 over 2. There is something that is definitely wrong and I have messed up somewhere. I have messed up somewhere. Oh no! Yes. This is a third. This is where it went wrong. This. Actually, this whole thing is just wrong. K 3k squared plus k plus 12k. I don't know why this is n. I didn't even realize. Plus 14 over 2 3k squared plus 13k plus 14 over 2. Now let's just check I am right. And my inductive step here should be this. I think this is where it goes messy, and I should have probably wrote it down somewhere before actually doing this. Yes. So if I actually rewrite this all nicely, my inductive step is going to be from n to n plus 2. If we do have valid partition from 1 all the way to 3n, 3k, actually 3n, then if I divide this into a subset of 3, and I'm going to call the sum of each of these subsets t, tn is equal to n times 3n plus 1 over 2. This is what we showed before from the s. I don't know why I changed to t midway. So going to tn and then tn plus 2, I am doing tn plus 6n plus 7 as I've introduced 3 more terms. And my 6 new numbers, I can pair them into into 3 different ways, each that add up to 6n plus 7. 3n plus 2, 3n plus 3, plus 3n plus 5, 3n plus 4 is equal to this and that. So I have basically shown by mathematical induction that this works. And I guess I haven't checked n equals 1 works. If n equals 1, then I have just 1 plus 2 plus 3. Um, and that clearly doesn't work because I can't split that into 3 disjoint subsets that have the same total, clearly. So, I mean, I'm not going to state that because it's obvious. But yeah, that's the way I did this question. Um, Now, I can do this question, it's just I haven't finished doing it. So it's going to be kind of me doing it midway, like coming up with a solution right now. So it's not perhaps the most good thing. Um, Also, I need to mention the fact that a lot of people have watched one of my videos, which is very interesting because I am not a YouTuber or want to be one. So it's a very peculiar phenomenon, and I am grateful, I guess. Um, and if you do like maths, I hope you can give me some feedback in the way I do my questions. And more importantly, I do think it's important to what do you call it? Do maths out loud, and especially if you're someone who's a bit shy or not confident, um, or you're just like me who likes someone who likes doing maths and desperately needs to improve, then I guess you're in the right place. But moving on, question 8. This is actually a question from yesterday. Again, yesterday I couldn't finish my questions because not only I crashed out, but it seems that my iPad doesn't think that I should do maths like late in the night, so it bugged out. But yeah, moving on. A sequence is defined by x1 equals to 1, x2 is equal to 1,000, and for n more than 3, my n term formula is xn is equal to the term before it, the modulus of the term before it, minus the modulus of the difference of my two previous terms. That's a nice way to put it. So if every time I see a sequence, and an n term formula, what I do is quickly generate a few terms and try to spot a pattern. So if I do that, so I have x1, which is 1, x2, which is 1,000. Now x3 is going to be 1,000 minus 1, and the modulus of that, which is 999. X4, which is 999 minus 1,000, which is minus 1. Yes, it's minus 1, but because I'm taking the modulus of it, I'll take the positive value of it. And x5 is going to be 1 minus 999, which is just 998, not negative because, again, I'm taking the modulus of it. So there is a pattern. If you keep on doing this, you will get, so if I draw a graph, n, x, and not a graph, a table, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to have 1,000, 999, 1, 9, 9, 8, 9, 9, 7, 1, 9, 9, 9, 6, 9, 9, 5, and 10 is 1. So there seems to be this pattern of you have 1 and 2 numbers that repeat. Now, I want to think about this. I want to reason through this in a quite lazy way. I'm going to have 1,000 numbers, each which come in pairs, and for every pair, I have two twos. So that means I am expecting to reach the end of the sequence, 1,999, 998, 97, 96, and so on. I'm going to expect that to reach 0 around the point x to the 2000. Now, you can stop the video and actually work it out until x to the 2000. I advise you, if you think time is valuable, then do not do that. But you are welcome to fact check me on that. But that's going to be what I'm going to expect. Actually, it might turn out to be that x 2000 is the first zeroth term. So there is going to be a sequence of 1 and 0. So my next term, x k plus 1, is going to be 1 minus 0, which is just 0. No, sorry, it's what? What the hell did I just say? 1 minus 0 is just 1. And then I have 1 minus 0, which is 1. And then I have 1 minus 1, which is 0. So now I'm going to have a repeating sequence of 1, 1, 0, 1, 1, 0, 1, 1, and so on. So now I can almost guess. I have a 50-50, almost 50-50 chance. It's either going to be a 1 or it's going to be a 0. So is x to the 2024 a 1 or 0? That's going to be the question. And the way I think I'm going to do that is I'm going to use modular arithmetic, perhaps. How would I do this? Okay, so I'm saying that in at the term x 2000, I'm going to reach 0. Okay, so I'm going to say this. Actually, I think x to the 2000 is 0 because I have 1,000 numbers plus 1,000 ones. So that's going to be 2,000 in total. So yeah, I'm pretty sure this is correct. So I'm gonna say 1, 2, 3, 4, 5, 6. And so on. 7, 8, 9, 10, 11, 12, 13, 14, 15. I can actually do this for quite long, but I'm not going to do that. I'm going to have, so I know 0, the pattern goes 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0. I need to scroll down. 1, 1, 0. And if I keep on doing this, 16, 17, 18, 19, 20, 21, 22, 1, 1, 0, 1, 1, 0, 1, 1, and 2024 is going to be 0. And I can definitely do that with modular arithmetic. I just haven't thought how to do it yet. But yeah, so my final answer, x to the 2024 is going to be 0. That's the way I would do this question, which is quite nice. It's just quite annoying. And I think you can check the code, check a Python code in like 5 minutes, write one, and actually do this. If I'm bothered, I might actually write one and show that my solution has to be correct. Okay, these are pretty much the questions I have for today. Unless I can do one more. I mean, I've spent half an hour and I am in school, so perhaps I should do better things than sit down by myself and do math questions. I think philosophically speaking, my loneliness and my doing maths by myself is going to be a thing of reward. So I don't have to think of it negatively. Um, yeah, I mean, I'm pretty satisfied with my solutions. They are nowhere good solutions. Do not think that I am anywhere of a good mathematician. I'm absolutely mediocre. If you haven't realized that yet, but again, what I can try to do and what I have to do if I want to succeed is I have to kind of fake it that I'm confident. Well, I'm really not. But if whoever is interviewing me for, let's say, Oxford, Cambridge, thinks I'm good enough, that's enough. Because once I get an offer, there is no way on earth that I'm missing my offer. I am genuinely going to make it my life's mission not to fail my A levels. Until then, all I can do is hope that things go well. Yeah, I think I'm elongating this video more than necessary, so I'm gonna end it there. Well, thank you for actually being bothered to listen. If you made it this far, then you are as jobless as me. So congratulations.